Hello community, September 25th, yes, 2024, and we have some beautiful new AI research. Have a look at this. It is called Steward. A user submits a task, system goes here on the web, goes to the websites. You don't need any API specifics anymore, just takes a screenshot on the of the website. Then we have an LLM, let's say OpenAI, does all the identification, understands what is clickable, what is a sequence of clicks. Maybe I have to input the date first, then the location, and then a specific time frame. All is analyzed here by an LLM. Then this performs here an action on the web, gets the result back to the user, and everything is fine. So this is a study here by the University of Michigan, Ann Arbor. It is called Steward Natural Language Web Automation Next Level. Beautiful. Next study. Seal. This is now talking here about an API use of LLMs. This is now a brand new study here, September 23rd, for evaluating API use. This is by Cornell University, and you are gonna be amazed about the performance of APIs by LLMs. If you're interested, have a look. Next study. Here we go now to some very interesting deep dive. And we have now the possibility to have here different agents, multi-role expert agents here, if we do something. And this here is a study by, where are we, Tsinghua University in China, Beijing, China, and they say here, liberal arts educational chatbot. But never mind, just think about an educational chatbot based on retrieval-augmented, multi-role, multi-expert collaboration. And you might say, okay, so what is so specific about this? Well, it is about teaching. And they have here some guidelines here about humanized communication, teaching expertise, and safety ethics. This is really important. And then you want to build here AI system that respect here all the ethical question, and also here, of course, the specific domain knowledge question, teaching skill. You want something about psychology, safety ethics, and so on. But you know what? What is simple? Okay, you define here different experts, different AI systems, a group of teacher, 3 agents, beautiful. A group of psychologists to a role-specific domain knowledge, beautiful. Safety expert, ethics expert. Doesn't this sound great? And they collaborate. And then for the students, they provide now if you want, an educational chatbot answers. What I found interesting is, so you have here all this information, study context, you have education theory, the class recordings, the literature, then you have, access to the internet, and you have all the documents. And then we are now at a position then some AI agents come together. Let's say the perfect group here is a teacher or a psychologist or some ethics expert, and they vote what of this documentation, let's say from the internet, is safe. Not is just only relevant to the topic of the question by the student, but they decide what is the correct answer by majority voting. And now let me ask you, if this is the chatbot that learns children, young people, students, new stuff, who is programming those agents that decide what kind of information is filtered out and what kind of information is presented to a specific student? And yes, you guessed it. Maybe you are a very rich student, your parents are very rich, maybe you can afford a better education, or you get the idea what it is interesting, what this structure would open up here for the education for young people. Great, next one. Talking about here new LLMs with students, there's also a publication here by the Artificial Intelligence Solution from Cairo, Egypt, Africa, and they are now focusing LLMs on mental illnesses. And first glance you might say, okay, but what they do is they now scan here, for example, whatever you posted on your platform, whatever you have, and then they decided here, hey, why not build an LLM model that decides on your posting that you did on your platforms that you like, and let's come up with a rating on mental illnesses. So here is is simple. No, you have disorder detection, disorder evaluation, a psychiatric knowledge assessment done by the AI on whatever you posted, whatever you communicated here. So real interesting that we are now able here to build LLMs that analyze whatever a free individual posted here, and they give you here the mental illnesses. Isn't this beautiful? Let's switch here the application, and you already see why I've chosen those publications of today. We are here September 24th, 2024, and let's look at now a multimodal, multilingual retrieval-augmented RAG generation for an asthma patient support. So you see, we switch here from mental illness, this is something also medical, to asthma. This is also a medical condition. And you see, people are pushing AI now into those topics. And I think this is interesting. This is here from the International University of Rabat in Morocco, Africa. And they here go in a cooperation with the University of Leeds in the UK. And they build now this multimodal, and I think this is the beautiful part, multimodal AI systems to help people answer questions about, and maybe also some real-time support for asthma people. We're already there that we apply those, hopefully in a very limited condition, now to real-world people. Let's talk about this, and let's go here to India. And we are here at the Indian Institute of Technology in Madras, Maharashtra. Beautiful. Hello over there. And now we talk about an automated assessment of AI, by AI, of multimodal answer sheets by human in the scientific domain. So if you are here at school and you do some writing, you have some text that you answer, maybe you do a drawing here of a parallelogram, or you give a graph as an answer, or your task is here some vector operation. So you need here multimodal answer capabilities that the system is understand this, and then you don't have the teacher who is evaluating the work of the students, but now you have an automated assessment by the AI system that is able to read here the multimodal answers, and the AI will vote on the performance of the humans if they do some exercise in school here. And grading subject offers several challenges to grade, such as the quantitative analysis, the complex mathematical concepts, wide range of formats, short answer responses, code snippets. Is this code snippet correct? And you see there is a whole bunch of complexity, but seems that this is already getting started to be integrated here in the real-world application. Talking about real-world application, we just find out here that latest research, Rochester Institute of Technology, Harvard Medical School, ByteDance, Meta, and University of Missouri, and a lot of other researchers go now to multimodal prompt tuning for zero-shot instruction learning. And you say, wait a minute, we still train the system on instruction learning? So these systems here, this multimodal system, they are still learning, and we already apply this here to our children, to the education domain, or maybe to young students? Well, surprise, surprise, technology is not waiting for anybody else. And Meta, ByteDance, Harvard, UC, those are institutions that are really interested to apply technology in everyday life. Let's put it this way. So we have here a new multimodal prompt tuning. We are here at prompt engineering, but now in the multimodal for zero-shot instruction learning. And they tell you, yes, you are for sure familiar with LoRa. And they say, yeah, we have a new idea for, if you want, the multi-domain and multimodal prompt engineering now for instruction learning of our LLMs. A real interesting study if you're familiar here with low-rank adaptation matrix, and I've showed you with Hadamard matrices, we have now an improved LoRa if you want, and now there is now another new idea, Harvard, ByteDance, Meta. Great. And on we go. And there's also a new methodological idea, as you see, by September 24, 2024, and this is now by Shanghai AI Laboratory. And you remember CLIP, no? We had this contrastive language image pre-training, CLIP, And now we have a new methodology. We have a contrastive language state pre-training. Why? Because we do have agents. And now in robotics, it is so important that you do not have just the sensory input data, but you also know about the state of your robot, of your agent. And what they do, they integrate now, if you want, in a very overview, I would say they have now this contrastive language state pre-training methodology, which can accurately encode the state information into general representation for both the reinforcement learning and multimodal LLMs. Real nice idea. They use your random Fourier features methodologies for the mapping. If you are into this, I highly recommend this. This is Clip Advanced now to the robotics agent state. On we go for the next one. Turning indirect knowledge into direct demonstration for digital agents at scale. And you see Carnegie Mellon University and Amazon AWS AI, you say, what are they doing? Now, as it turns out, you need your digital agents. You have to train your digital agents, and you know what? There's not enough training data. So what you do, you look here for manuals that were written for humans, and you try to understand the contents of the manuals for human and transfer those manuals into synthetic data for training your AI systems. You run out of digital data for your agent, and now the idea is here, there's an abundant knowledge that may indirectly assist here the AI task completion, such as online tutorials that were created for human consumption. So the AI says, hey, great, you don't provide me with enough training data. So I just look at all the human training data, how humans prepared information for other humans, and I will just modify this and I will train myself as an AI engine on those human data. Yeah, of course, and they say, you know what, it is really cheap because those synthetic demonstrations prove to be only 3% of the cost of the human demonstration. So, my goodness, Amazon just needs to pay 3% of the human training data. What a beautiful idea, no? What do you think about this? A new study, September 24, yes, passive watching to active learning. Now let's do the same thing, and we are here at the Technical University of Munich. But now we say, okay, now we have an AI tutor, an AI video assistant. And now the humans are learning from AI. And you might say, hey, wait a minute, we just had that the AI is learning from the human knowledge. And now we have a study that shows us here for young students or for children or whatever, how is it possible that now an AI tutor is learning here or providing information to humans to learn? Yeah, isn't this beautiful? And I guess you get a feeling which new research papers I selected that we see here, the real current application of AI. Isn't this beautiful? So, in online education, tools are crucial for enhancing here the human learning. And Sam here, a study with AI Mentor, what a beautiful abbreviation, is a platform that integrates educational videos with a context-aware chat interface by an agent, powered here by any LLMs. And this encourages your student to ask questions after seeing this video, asking here, hey, did you understand it? Do you hear a simple example? What has been unclear? And then our little AI system tries to provide additional information. So if something was not mentioned in the video, you have an AI bot that was now trained for education. Interesting what people all around the world, as I told you, many come up with solution for implementing this. This is a study where no PDF exists. It was deleted, okay, but never mind. We go here from in-context ensemble, and it is more or less also, we have here video language model for low-level workflow understanding from human demonstration. And you see, I stick to the topic. We have human materials from human by human. And now the question is how we can take now a video that was designed for humans and extract the text and make it a learning data set for AI. And the idea here is to go from in-context learning to in-context ensemble learning. Yes, of course, we have video data, and they go here with the typical standard operating procedure. So we are here in a video understanding task to generate here texts. You see what's happening? Let's look at this one. Next one, September 24, planning in the dark. LLM, and now symbolic planning pipeline with other experts. And we are here in Australia, University of Melbourne. Hello, down under. Isn't this beautiful? Now, the idea is simple. All these LLMs, they can't do everything. So if you have a specific task, you have a table and you have 3 books, and you say, hey, place now book 2 on top of book 3 and book 1 on top of book 2. You understand here exactly what you want. You have an initial state and you have a goal state. And now you give this here to a language model and you say, hey, do all the reasoning, do all the planning, go through all the possible solutions. How is it possible that we reshuffle here, that we finally end up in the goal state of the system? The idea is here, hey, LLMs are not really the optimal tool to do this, but if you add an LLM and a symbolic planning pipeline, so we do have a tool use, function call, a tool use, and we have here a symbolic planner that can do this very easily. Hey, why not use here the AI plus a specific tool for the job that comes back with the perfect plan, and then we can be sure this has a high probability of success. These are it in my simple words, beautiful, and we go on. I'm talking about here planning, talking about a sequence of steps, talking about here a logic sequence. We are now looking here, September 24, at a PyTorch implementation of a logic tensor network. This is done by the Department of Mathematics, University of Padova in Italy. Hello, Italy. You see, we're really traveling the world. Now, you might say, hey, wait a minute, the logic tensor network. This is something that you might be familiar with. Because this is also here the implementation in TensorFlow. And this happened about, latest one, March 2022. So this is more than 2 years old, but there was only a TensorFlow implementation. And what happened here, you remember here in 2021, there was this publication about a logic tensor network here. Interestingly, in Tokyo, Japan, now we're on the other side of the world, Sony Computer Science Laboratories. And also, as you see, train to Italy and London. So we had the idea in 2021. Then we moved over here to the TensorFlow implementation in 2022. And now in 2024, finally, we have the PyTorch implementation of the logic tensor networks. Isn't this great? Now, talking about this, and this is now the last new idea I want to show you. There is now also here a new study, September 24, efficiently learning probabilistic logic models by cheaply ranking mind rules. So we have here Edinburgh, University of Edinburgh and Cambridge, Samsung, artificial intelligence, interesting. And they look now at this neuro-symbolic AI. And hopefully it seems that everybody's understanding, don't put everything into the LLM, but give the LLM the right tools to do the job. So they go now here, say, okay, we have here LLM, and we have some logic models, like a probabilistic logic models. And they form now the new core of some advanced neuro-symbolic artificial intelligence. And they want here a higher explainability. Real nice, they introduce here Spectrum, a scalable framework for learning logical models from relational data. So if you are into pure logic and the implementation of logical tools for LLMs, for AI agents, as a real tool to be applied, this is a real beautiful study. They give you here state of the art and everything, and then they explain here that the 3 contribution that they provide here in this paper. And if you are into logic, you're really gonna enjoy this paper here. They operate, of course, with hypergraphs here. So they combine what you know maybe here from the LLMs, from the graph theory, from the graph neural network, from the logical deduction patterns here, from the reasoning engines that we have. And now they bring this here together and let's say, hey, let's find here the logical rules of the system. Highly interesting. You see, all of this happened here today, September 24, 2024. Isn't this a coincidence, or maybe this is an indication that worldwide the research of AI is now more and more focusing on core LLMs plus tools, specific logical models, specific probabilistic logical models for doing here the planning, the reasoning, and as you see, every study more or less was focusing on multimodal AI systems. So at least we have a vision model and a text model, plus maybe an audio model, and we are moving gradually to video learning, video tutors, video analysis, video text translations, and how to integrate here, and the prompt engineering here based here on multimodal prompt engineering. You see, the complexity of AI goes up significantly. And this was just September 24, 2024. I hope you enjoyed it. I hope you had some fun. It would be great to see you in my next video.